non-variable and non-deformed. Spray liquid fiber onto the fabric. Prepare the bioplastic polylactic acid, which is also known as PLA. This stuff has a low melting point and high strength. It has good adhesion, so it is often used for 3D printing beakers. First, add 100 milliliters of ethyl acetate. Then add 8 grams of PLA. Place the beaker in the pot. Heat the temperature to about 60 degrees using a water bath. After dissolving, inject 8 milliliters of 91% isopropyl alcohol. Weigh 0.08 grams. Add 1 mole of 1 million molecular weight polyethylene oxide. Mix well. The fiber solution is ready. Continue. Make it into fabric. Pour the liquid fiber into a plastic bottle. Twist it onto the front of the exhaust fan. Then poke a hole. It will spray out the fibers when it spins.
Turn it on from the back.
There it is. See it? Place a very fine metal mesh in front to catch it, strand by strand. Spraying out the fibers. The fiber solution is sprayed into the air, and then blown by the exhaust fan behind it. The solvent evaporates quickly. The fibers reach the metal mesh. They intertwine and bond together, layer upon layer, ultimately forming the fabric. The distance between the metal mesh and the plastic bottle is very crucial. Like this, it's almost dry. It's okay if it reaches the metal mesh while still sticky. The basic principle is similar to papermaking. Both use a fine mesh to catch the fibers. The feeling of it in your hand. It's like a spider web. It's not spraying out well. Let's open it and take a look. There's nothing inside. Add more and it can spray again. Sometimes it doesn't work. It may also be that the nozzle is blocked.
Just take it apart and it will work again.
Take a little bit off. Check if it's strong enough. Almost there.
Take it off first.
It's still good even though it's torn. There's still a big piece underneath. This really looks like Shein paper used for calligraphy. Only this thick after spraying 10 times. Still translucent. It's really thin. If it's for opening hooks, you can only hang it with a buckle. Another problem is that when the temperature is too low, the solution solidifies a bit. The fibers that come out are very coarse. Even using an air gun won't work. See, it's sticky when blown. Oh my. Just like snot. The effect is also very disappointing. I had to make some slight modifications. It looks complicated. Actually, it's very simple. The dehumidifying skin is still at the very front. It can be easily removed. There's a metal tube in the middle. It acts as a rotating shaft that goes all the way to the back. This hollow tube is not only a rotating shaft but also the liquid fiber feeding port. There's a variable speed electric drill to drive it. There's a hairdryer on the left. It can maintain the temperature. Prevent the solution from solidifying. A plastic mesh tube. Raise the inlet to the top. To prevent it from rotating, there are holes in the tube. You can put a metal tube on the outside. Then this problem can be solved. Align the position. The tube is plugged in well. This is much more convenient. Unlike the beginning, the solution is gone. You have to open the bottle. Inject the fiber solution with a syringe. This time, I also put the mesh on a bicycle wheel. Letting it rotate, it won't receive unevenly like at the beginning. It would break with a tear. The fibers that are swung meet the metal mesh that is swung. Will form in the lower right corner. This pattern can be uniform and dense, and regularly intertwined with each other. And the electric drill can also adjust the speed. Can be adjusted at any time according to the situation. The whole device is made of some household items. Very simple, wow. Look, this time the effect is good. Such a big piece. Do you see? Tear it casually and it won't break.
This is called cloth.
Didn't take off a single piece. Great. I went outside and took a thermal image. This thing is actually cooler than the ambient temperature. See? It's covered in black. This area is obviously much cooler. This is promising. I just made a few more. This thing is fun to pull apart, like a pancake. Prepare a straw hat. Draw a line around the brim. Then slowly cut it out. Stack the two pieces together. Then hollow out the middle part of the hat. This creates a contrast between the center and the sides. Go outside and let it dry in the sun. It dried for half an hour. You can see the uncovered part of the hat. The temperature is significantly higher. Why is the temperature of the bottom layer relatively high? It's about the same temperature as the original hat. But it doesn't transfer the temperature to the surface. This layer is interesting. It's like a polar bear. With light-colored fur, which can reflect a lot of sunlight. And the black skin under the fur can absorb heat. To maintain temperature, add a layer of aluminum foil in between the two layers. To increase thermal conductivity. See if there's any difference. The same as before. Still testing on the hat. Aluminum foil is added in the middle of the right side. The left side has 2 layers of fabric. Still exposing it to the sun. See? Indeed, it's different. The right side has been affected by the bottom layer. Let's take a look at the left side. It's still the same as before. It's very hot inside, but it doesn't transfer the temperature to the surface. The insulation performance is so good. If this were made into clothes and worn in winter.
I wonder if I could stay in the Arctic.